Welcome, everybody. We're so delighted to see everyone here today. My name is Amy Schulz, and I am on the faculty at the University of Michigan School of Public Health and co-lead with Barbara Israel in the front of the room here for the Community Engagement Core for the M-LEEaD Core Center, which is one of the sponsoring organizations, and you'll hear a little bit more about that in a moment. We're so delighted to have everybody here today. I particularly want to welcome the 200-odd people who are joining us by live stream webinar today. You should have all received an email this morning with instructions for the live stream and also with instructions for submitting questions when we get to the Q&A sections of the following each speaker. Send those in to us. We'll have somebody monitoring those, and you'll be able to ask questions of the speakers. So we knew we were taking a really big risk to organize a seminar in February in Michigan. So we're really pleased that the weather was with us. We have sunshine today, and that everybody was able to make it here from various parts of the state, and also particularly welcome folks who traveled from outside the state to make it here. How many of the people in the room were able to attend the film premiere last night? Fabulous. It was a wonderful premiere. Thank you to Tony and all the others who were instrumental in making that happen. I think it really set the tone for the conversation that we're hoping to have today. Before we begin, I want to do an acknowledgement. The University of Michigan was founded in 1817 through a treaty called the Treaty of Fort Meigs. And it was when the Anishinaabe, the Three Fires Confederacy of the Ojibwe, the Odawa, and the Potawatomi, along with a number of their neighboring tribes, were convinced to cede portions of their land in the hope that their children would be educated in the university that was to be built on that land. The relinquishment of this land during this particular historical moment came at great cost to the indigenous communities who turned it over. And the hope of educational opportunities for their children has only been very partially realized. As we begin today's conversation, I want to acknowledge, renew, and affirm the ancestral, traditional, and contemporary ties of the Anishinaabe to this land and to the founding of the university. I also want to begin with a few additional acknowledgments and huge thanks to people who made today possible. First of all, to our planning team, Jody Brustowitz, Brittany Fremion, Michelle Marcus, Meredith McGeehee, Melanie Pearson, Christina Rice, Jean Steppe, and Robin Wiley. Thank you guys so much for all of your contributions to making the day happen. I also want to give a shout out to our poster reviewers, Sung Kyung Park, Rick Radisky, and Barbara Israel for looking at the posters and evaluating them. I also want to give a thanks to the Pine River Superfund Citizen Task Force that were really the impetus behind this conversation. This group has been working on the PBB cleanup, the cleanup of the PBB contamination in St. Louis, Michigan for 40 years? 45 years, and as they began to see the events unfold around the PFAS contamination, kept saying, we really need to talk. We've seen this before, and we need to have a conversation about this. So thank you for being the inspiration behind today's conference. The third thank you I want to give is to the members of the M-LEEaD Center Stakeholder Advisory Board, a number of whom are in the room today and who have been instrumental in planning this day, and several of whom you're going to meet throughout the day in various roles. And finally, I want to thank our co-sponsors for this event, the M-LEEaD Core Center at the University of Michigan, the HERCULES Exposome Center at Emory University, Central Michigan University, the University of Michigan School of Public Health, the Graham Sustainability Institute, the Michigan Institute for Clinical and Health Research, and we the people of Detroit, who all contributed to making the day happen. Let's give them a hand. Okay, So our overarching objective for the day today is to bring together scientists and community members, some of whom are also scientists, for dialogue to inform action. It's a point that Drs. Marsit and Dolinoy are going to discuss in greater depth in just a moment, but I do want to just give a heads up. Toward that end, we're going to have a series of talks this morning of various perspectives on the issues that we're engaged with today, and then in the afternoon we're going to be moving into small breakout groups to do forward planning around what needs to happen next, around a specific set of issues. We have identified a priori 5 issues for the breakout groups: the role of health departments and state registries, policy change, preparing the next generation of researchers and activists, community research collaborations, and building national networks and movements. We also are anticipating that other topics may bubble up as we have conversations over the course of the day. If you have a burning issue that you would like to convene a group to talk about later this afternoon, we have newsprint sheets out by the registration desk. Please post your issue on those newsprints at any point during the day. And then when we get ready to do the breakouts in the afternoon, we will add those to the list, and there'll be opportunities to for folks to go and have a conversation. Okay. I think that's all I have to say, Meredith. Did I forget anything business-wise? All right. Then I am going to yield the floor to Carmen Marsit and Dana Dolinoy, who are going to introduce our keynote speaker.
Amy, thank you very much, and thank you to everybody for attending today. As Amy mentioned, this meeting grew out of a partnership that was established between the communities affected by the PBB exposures in Michigan and Emory investigators led by Michelle Marcus and Melanie Pearson, who maintain the PBB registry and who have established an absolutely exemplary program of community-engaged research. These investigators are absolutely committed to addressing and detailing the health concerns of the individuals who have been exposed to PBB, and I couldn't be more proud to direct a center that has these people as part of it. Building from this work in 2018, as part of an administrative supplement to the NIEHS Core Research Centers program, Emory's HERCULES Exposome Research Center, along with the Michigan M-LEEaD Center and Central Michigan University, developed a community-engaged research project that was to gather and analyze the oral histories and documents from the individuals that were exposed to PBB. This was aimed at identifying environmental health literacy themes and direct programming efforts that could be used to communicate effectively with stakeholders. And they have done a great job at moving this work forward. This has led to a number of community meetings with various types of groups, including the Michigan State Legislature, and has really brought us together today. I mean, it's really from this work that we've developed this symposium today. And we're really now being able to make these connections between these forever chemicals, PBB, PCBs, PFAS, that are really affecting lives of people throughout the country. So I thank these investigators and their community partners for helping to bring us together and doing an incredible job of moving this work forward and keeping the community's concerns really at the forefront of the science that they're doing. So I'll now turn the podium over to my friend and colleague, Dana Dolinoy, who's the director of the Michigan M-LEEaD Center. Dana.
Thanks, Carmen.
Good morning, everybody, and welcome to sunny Ann Arbor, especially to our friends from the South, and also we have other people visiting from out of state, so welcome. I'd also like to thank Amy Schulz and her team for organizing this, as well as our Emory partners and the Stakeholder Advisory Board. But now it is my distinct pleasure to welcome Dr. Linda Birnbaum, retired director of the National Institute of Environmental Health Sciences, of the National Institute of Health and the National Toxicology Program from 2009 to October of 2019 to deliver our keynote address. Dr. Birnbaum is a board-certified toxicologist serving as a federal scientist for over 40 years. Prior to her appointment at NIEHS, Dr. Birnbaum spent 19 years at the U.S. Environmental Protection Agency, where she directed the largest division focusing on environmental health research. A native to Passaic, New Jersey, which you may not know is where my parents grew up, Dr. Birnbaum received her MS and PhD in microbiology from the University of Illinois, and she has authored more than 700 peer-reviewed publications, book chapters, and reports. Dr. Birnbaum's research focuses on pharmacokinetic, behavior of environmental chemicals, mechanisms of action of toxicants, including endocrine disruption, and the linking of real-world exposures to health effects. Dr. Birnbaum has received many awards and recognitions, including in October of 2010, she was elected to the Institute of Medicine of the National Academies, which is one of the highest honors in the field of medicine and health. Other awards include 2 NIH Directors Award, the Women in Toxicology Award, the Society of Toxicology Public Communication Award, and the EPA Health Scientist Achievement Award and Diversity Leadership Award. To quote Dr. Birnbaum's long-term friend and collaborator, Michelle Marcus, one of the greatest strengths of Dr. Birnbaum that she brings to the field is her ability to understand the science from the molecular to the population. Although trained as a toxicologist, she has embraced all of the data relevant to protecting human health, and during her tenure at NIEHS, she has promoted community engagement at every level. The NIEHS P30 mechanisms, which the M-LEEaD and HERCULES Center are part of, funds core research centers and requires community scientist partnerships. Thus, funds can be devoted to working with communities, to holding interactive community meetings, such as this one, and compensating community members for their input on research priorities. In many ways, through her support of the community engagement of the P30 cores, Dr. Birnbaum is the one that enabled us all to be here today to convene this important conference. And with that, Dr. Birnbaum, I'd like to welcome you to give your keynote address.
Okay, let's see how I get it up here. Okay. Gotta find it on here.
It should be on the desk.
My channel. This one?
Try that.
Aha, perfect.
Okay.
Now all I have to do is go to slideshow, which is right down.
Is it that one?
Yep. Very good.
Yep.
Okay, so first of all, it's always a pleasure for me to come back to Michigan. I did spend, 8 to 10 years chairing the Science Advisory Board for the School of Public Health study on dioxin exposure, focusing in the Midland area. So I had the pleasure of being here quite a bit. And I've been here a couple of other times to give talks or meet with people, but always happy to come. I will say it's gorgeous here. It's snowing in North Carolina. Anyway, we shall see. Anyhow, what I'd like to do today really is do a whirlwind tour from PBB to PFAS. And what I wanted to show you to begin with is long ago, I would say, and far away, but one of my first things I did when I went to NIEHS in 1979 as a young tenure-track scientist was I studied hexabromonaphthalene. Hexabromonaphthalines are contaminants of the PBBs. And in fact, they are the dioxin-like components of the PBB mixture. And I know that many of the effects that have been reported, both the acute and some of the long-term effects that are being seen, are really related to the AH receptor, which is the mechanism. And so this was one of the first studies that I did really related to PBBs. But my focus was really on dioxins. So in the 1980s, among the other studies I did, I actually published 3 papers on perfluorodecanoic acid. That's the C10, the relative of PFOA. And the question I was asking, we knew that these chemicals caused an increase in liver weight and they affected thyroid hormones. And I said, oh, these must be dioxins. Well, I showed they weren't. And since I was focusing on dioxin, I walked away from this area. Sometimes you make choices that come back to bite you. Anyhow, I'm back in the field right now and very, very excited. I could say I'm sorry I'm back in the field, because why in the heck are we all being exposed, every one of us in this room, to this class of chemicals? So this is just a couple of them. I'll go through these quickly. These are a couple newspaper headlines that I pulled out. These I actually pulled out, I think, this summer, but there's picture of foam. Those of you who were at the movies last night, which at least I made after my flight was 2 hours late from Washington. But anyhow, what you can see is the tremendous amount of foam that's we find in, this is downstream from 3M. Okay, I'm going to remind you that 3M stopped making PFOS in 2002. It was a voluntary agreement, and DuPont, well, 3M was actually the source of PFOA that led to the contamination, like in the Ohio River Valley, but DuPont stopped making it in about 2012 or something. They kind of turned it over to Chemours, which is in my neighborhood. And I can tell you at some point about the contamination we have in North Carolina. Anyhow, there's the Van Eaton Lake. Van Eaton are entering the lake. That's from a picture from sometime last year. And then there was just something about, the Clovis City water in New Mexico. We saw a farmer from New Mexico on the film last night, and we know if you live near a major Air Force base, in fact, I would argue if you live near any military base, any main firefighting station, any emergency thing, you're going to find that there's PFAS all around you. And then the other one that we have over here is that was from Clovis City. Oh, that's from Clovis City, New Mexico. I'm sorry, I'm going ahead. And then this was just in one of your papers recently about all the PFAS in the Saginaw River. Now, I'm pretty familiar with the Saginaw from the dioxins and the PCBs that contaminate it. I guess, why would we think it wouldn't have these other persistent organic chemicals in the water? And then I was very interested to read just about a month ago about how the state of Michigan is now suing 17 chemical companies for PFAS contamination. Maybe a little late, but better than never. So we've got that. So really, what are the per and polyfluoroalkyl substance? I have to tell you, the acronym PFAS is horrible. It's a horrible choice because I say PFAS to get the A in there, because there's also PFOS, which is a specific chemical. But the point is, this is a huge class. There are over 5,000 of these chemicals that have been intentionally synthesized. That doesn't mean there aren't more that turn out to be breakdown products of much longer chain or branch chain molecules that are being broken down in the atmosphere. Sometimes what do they give us? PFOA, PFOS, PFHXS, you kind of name it, going on down. And frankly, we don't know the totality of what's being made out there. Why do we have them? We have them because they have very, very useful properties. They're resistant to grease and water and oil, they're surfactants, they're stain repellents. I have to tell you, I bought a pair of really nice shoes, hiking shoes recently, and on the box is a big sign that says, totally water resistant. And I said, I don't want them, because I know what that means. Anyway, and then we also know that they've been extensively used for fire suppression in the AFFF. What you might hear from some of the defense folks is that only 3 to 6% of AFFF is PFAS. Like that's okay when you use tons and tons and tons of this stuff. That adds up. What are the problems with them? They are persistent, and many of them are bioaccumulative. They are so persistent in the environment, as you all know, they're called the forever chemicals. I think I'm the one who actually coined that about a year ago, but the point is they are never going to leave the environment. They barely occur in nature. There is no natural way to break them down. They are very difficult to break that carbon-fluorine bond. In fact, we're being uniquely unsuccessful at doing that. So once they're made, we're going to have them in the environment, whether they persist in our bodies or not. And things that only are in our bodies for short periods of time, that doesn't mean that they're safe. And again, we have all the short-chain alternatives. So what I have up here on the bottom, you have PFOS and PFOA, and then you have some of what are called the short chains. Again, terrible nomenclature. What it means is that you don't have as long a run of carbons with fluorines. You break it up with something. You may only have 4 carbons or 5 carbons, or you may have 3 carbons and an oxygen and then another 3 carbons and then an oxygen and another 3 carbons. Those are called short chains. And the idea is that these won't last in our bodies, but they will last in the environment. So how are we exposed? I've already given you some of the hint about that. These are a very diverse group of chemicals, and they haven't been around for 40 years, guys. They've been around for 60 years. In fact, they were really first made in the 1940s in a lab where they were first synthesized. But they're in your carpet and fabric. I should tell you that Home Depot and Lowe's no longer are having these put on any carpets you get there. It's good news. They're on lots of different kinds of paper that's used on food. So, you know, the thing your hamburger's wrapped in when you get it from your fast food stop. Pots and pans. Just a warning. When you go to wherever you go and you see these new nonstick pans and there are big signs on them that say, no PFOA, what should that tell you immediately? It's got a short chain one in there, immediately. Unless it says no PFAS, beware. It's on lots of our clothing. It's, again, cardboard packaging and firefighting foams, of course. And one thing I want to mention is so much of the focus lately has been on what's in our water, our drinking water and our groundwater. Remember, it's also in our food. And guess what? It's in our air, too. And there has been no work done, really, on the inhalation. And I can tell you, if things are inhaled, they're going to go to different places in our bodies, and different things may happen to them. So this is just a quick schematic from Elsie Sutherland of Harvard, where she was putting together the different, let's see, oh, wait, goody, I do have a pointer. Whoops, a little too aggressive there. Oh, forget it. I'm going to go back to the slideshow. Let's see if we can get it to the right place. If one of my grandkids were here, they would do it immediately. Whoops. Okay, back to PFAS exposure. What you can see here is the industry is making it. It goes into AFFF. It goes into loads of consumer products. And from the different sources, it gets into the waste infrastructure and the stream, and we get exposed. And I would remind you that who among us have some of the highest levels? It's our newborn babies and our infants, because these compounds cross the placenta, and they are transferred through breast milk as well. Breast is still best, people, please. You know, still best to nurse your baby, but why should that have to be something you even think about, is the safety of your breast milk. Okay, so I think important thing when we talk about water as a source of exposure, this is a study that was really, I think, kind of got the issue up and running again in 2016, where using EPA's own data from their Chemicals of Emerging Concern network, what they found was that there were at least 6 million people across the country who were exposed to elevated levels of PFAS. Now, that's a funny definition, because what do they mean by elevated? You have to go back and actually look and find that their levels of detection were very high at that point in time. So in fact, the Environmental Working Group a year or two later said, no, it's about 110 million people are exposed to elevated levels in their drinking water, when in fact you looked more carefully. But the really important point here is that if you live, or if your water is near a production source or a use source, it's going to be more elevated. So you have, for example, the stuff there about the industrial sites, and for example, if the AFFF was used, for example, or if you're near a water treatment plant. I should tell you that biosolids coming out of water treatment plants should probably be considered hazardous waste in most cases. At least I can tell you it is true in North Carolina. Okay, so what about contamination due to AFFF? This is a study that was done as a community-based study. When I was at NIEHS, and they're continuing it, we ran a program called Time-Sensitive Awards, because sometimes you have a contamination incident, and if it takes you a year to get funding to study it, it's already gone. So you've got to be able to get in there more quickly, and these are awards that can be done within about 90 to 120 days. And this was a study done near Colorado Springs. You all know there's a large Air Force, that's where the Air Force Academy is, and there's a large Air Force base there, and communities in the area are highly contaminated. And so went in and did a study, John Adgate from University of Colorado University, School of Public Health, went in and he looked at, he measured additional PFAS compared to, in addition to these. But what you can see is, what's the contamination? PFHXS and PFOS are the major contaminants. And those are signatures for AFFF. And so that was important studies. Okay, so I've talked about water. I wanted to mention the fast food packaging issue. And again, this was a study where they actually measured total fluorine using a method called PIGGY, where they actually look at what's in the molecule, total organic fluorine. That's important. You know, we all know that in many places we have fluoride in our drinking water, inorganic fluoride for our teeth. But this is organic fluoride, and this is looking at solid surfaces. But what you can see, your dessert and your food wrappers are highly contaminated and are the most contaminated. And then your sandwich and burger wrappers, and then paperboard. Paper cups seemed okay. This was a study of about 400 samples. And the group went in and they actually did high-resolution mass spectroscopy on a small sample of the things, and were able to actually identify that the most common PFAS in their samples were PFOA, and then two short chains, PFHXS and PFBS, and the 6,2-fluorotelomere sulfonate. Okay, I'll tell you that these 6,2, the fluorotelomere sulfonates and the fluorotelomere alcohols break down to give you the PFOA and the PFOS kinds of chemicals as well. Now, this was an interesting study that came out I think it was just last summer, where this was comparing the levels of, in serum, of some of the, quote, long-chain ones, PFDA, PFNA, PFOA. So DA is 10, and that's 9, and that's 8 carbons, and PFOS. And what you see is that in most cases, there are elevated levels in the people who ate a lot of fast food. And the dark circles are African Americans in this population versus non-Hispanic white Americans, and what you can see again. And this appears to be associated actually with the amount of fast food consumption. And possibly the amount of fast food, it turns out French fries were a major contributor in this study. But the point is, we all have PFAS in our bodies. I kind of started out saying that. And this is not just in the United States or in developed countries, it's all over the world. I'm going to show you a slide later from Alaska, where our Native American peoples there have elevated levels of PFAS. These things, like all the POPs, although PFAS are very different than the dioxins and the PCBs or the DDT, because they don't stay in your fat. They tend to bind to proteins so that they're, for example, we know they're in our blood. I'm going to show you some data that makes us wonder, do we really know where else they are in our body? But the point is that, you know, these things travel. They're highly mobile, so that, you know, our people, as well as our animals who are at the top of the food chain, are more contaminated, and these things undergo global distillation, so they volatilize in temperate climates, and then they come down where it gets closed. So the Arctic is quite highly contaminated, for example, and this is all over the world. And while PFOA and PFOS are not made intentionally in the US anymore, they're made in China. Okay. We could talk sometime about maybe why the outbreak of coronavirus, you know, could people be immunosuppressed? It's a whole nother issue. But anyway, but this is just looking at the levels. The good news is, since in the US they stopped producing PFOA and PFOS intentionally, if you look up here, what you can see is the levels of those have come down, but they've actually started to plateau, which is just like we saw with the PCBs, you know, because they're recirculating in the environment. And that there's really no change for some of the ones that haven't been regulated at all or drawn much attention. So this is the table I was telling you about. This is actually the only study I know which looked at autopsy specimens. And this was done in Catalonia in northern Spain. And I think the point that I want to make here is look at how much of the short chain PFBA and PFHXA there are in the lung. Okay? And for example, PFA, I can understand why it's in the kidney, because the kidney, it may be getting eliminated through the kidney, but look at the lung, and then look at the brain levels for some of them. We need another study, somebody else, I keep pushing, somebody. You know, if you do a study of autopsy specimens, it's not considered human research, so you can get it done sooner. I mean, it doesn't require the same level of scrutiny. But I think that it's interesting. You can see, again, the PFO, in the liver, the PFOS is elevated, But look at all the PFOA in the bone. And in fact, a recent study came from Finland demonstrating impacts of these kind of chemicals, the PFAS on the bone. This was another, just was comparing some of the levels in different areas of the world. So for example, where you have contamination and not. So the top gives you an idea of the C8 study, that's the study in the Ohio Valley, and I hope many of you have seen Dark Waters. If not, I kind of recommend it. It's the study of how that contamination was revealed and how some satisfaction was achieved for the residents and the people of that area. But what you can see here is that the PFOA was elevated. People forget PFOS was elevated too in that population. And so compared to NHANES in 2013 and 2015, but then huge contamination in the Venice area of Italy. I mean, it's a major contamination site, and they're doing some really nice work following up the population there. So you can see in Veneto, this was some data that they sent me from their doing an updated health surveillance as well as a biomonitoring of the population in that area. And what you can see is how high the level of PFOA was in that population. And they are seeing impacts on cholesterol levels and other lipid levels, and they're following children as well as the adults in that population, so interesting one to follow. This is just showing that this is some very interesting data. Gloria Post is probably the world's guru on PFOA. She's with the New Jersey Department of Environmental Protection, and this is just looking at the blood levels. You can predict them as drinking water levels rise. So I think it may have been in the film last night, or maybe it was in the discussion, can't remember, but the point is that if your water isn't heavily contaminated, you're getting your PFAS from your food and the dust in your house that's coming off your carpets, et cetera. But if your water's contaminated, that's going to be your major source. And you can roughly use a factor roughly of 100 to go from the level of water multiplied by 100, and that'll give you an idea of what the level might be in your serum, in your blood. So it's just a rough calculation that you can use. Okay, nobody's got to memorize the laundry list, and I think in this group you may have a good idea of how broad and wide this is. So I'm busy calling PFAS the dioxins or the PCBs of the 21st century because, again, you have a large group of chemicals, actually larger than the PCBs or the dioxin, that cause a plethora of effects in multiple tissues, both males and females, many life stages, and across the vertebrate kingdom. Why would anyone think that some people would not be responsive? I mean, I just put it that way. So anyway, this is kind of a list. You know, many of these things have been really seen very clearly in the large C8 study, but they've also been reported in a growing list of other epidemiological investigations. The cancer, testicular, kidney, there's also indications that there may be other cancers as well. Remember, cancer is not, you got to have a big population, and you got to get the good data. Ulcerative colitis, which is an autoimmune disease, so it affects on the immune system. High cholesterol, pregnancy-induced hypertension, thyroid disruption, hormone changes, liver, obesity, immunotoxicity. I'm going to show you just like brief data on some of these. Lower birth weight and size, delayed puberty, decreased fertility, early menopause, reduced testosterone, prostate cancer, ovarian cancer, changes in bone density. And I can add on to this. This is not a complete list. But this is, I would say, most of these are pretty well documented in multiple studies. So this is, the NTP did a systematic review of the immune effects of PFOA and PFOS that was published, peer-reviewed and published in 2016. And what they found was that there was really clear evidence in multiple animal species. You know, I'm not just talking rats, I'm not just talking mice, I'm also talking monkeys. And there is also evidence from humans. And some of the human data is shown on your right, which is the suppression of the antibody response to diphtheria. And this is associated with both in utero and childhood exposure. So we've seen this before. These are actually studies coming out of birth cohorts in the Faroe Islands. Philippe Grandjean and his colleagues have been following since the 1980s. essentially almost every child born in the Faroe Islands over this time. But they've looked at the kids after they get an antibody booster, they look several months later, and they've looked at age 5 and age 7 and now even age 13. And these kids, they cannot mount a normal antibody response. What does that mean? Should we ask the question, are some of the measles cases not because people weren't vaccinated, but in fact they didn't have a therapeutic response? I mean, I think those are questions that we should begin to be asking. And I can tell you, these results have basically been replicated in northern Japan in the Hokkaido birth cohort, and they've also, some of these kinds of things have been seen in several others as well. Ongoing PFOA exposures are associated with abnormal gestational weight gain. You can see in the dotted line there that the women with the higher levels are gaining weight faster during pregnancy, and there appears to be an association with an increase in gestational diabetes related, especially, for example, to PFOS and PFHXS, but there does seem to be an association there. And the concern here is that gestational diabetes increases the risk for type 2 diabetes later on. So I think this is again another study looking at the relationship between PFOS concentrations and the risk of type 2 diabetes. One thing I want to point out here is it looks like the greatest risk is maybe associated with the lowest exposure. And then basically, if you're sensitive, and that's a point to remember, not everybody's equally susceptible. There's a genetic basis, there's what else is going on in your life, there are other stressors and so on. But I think it's important to realize that, you may see the greatest effect at the lowest exposure levels. But again, there are multiple studies now showing associations between PFAS and type 2 diabetes. And then this is an interesting study showing that, and I think this is kind of vive la différence, boys and girls are not the same. I can tell you years ago when I was doing lots of stuff in the labs, if I didn't get the same result with my male and female rats, I thought there was something wrong with my experiment. Now I know there was something right with my experiment because, in fact, they can respond differently. But the important point here is that both birth weight and head circumference, there is an increase, a decrease in birth weight and an increase in head circumference, and it's greater in the boys than in the girls here. So there's also effects on a developmental neurotoxic effect that's been observed. So this is just, I've pulled out just snippets of data to show you. But some of the data here showing the increased PFNA, that's the C9 relative of PFOA. And the point here is these are all different measures of executive function in the brain. And without looking at my notes, I can't tell you, I don't remember exactly which each one means, but they are all, and what you can see is that this is especially true by 8 years of age. And I think that's an important thing for us to remember. Things can happen due to early life exposure that you don't see immediately, that it can take 3 years, 8 years, 20 years, 40 years before you actually see the impacts. But clearly an impact on brain function in children following early life exposure. And then there are lots of studies associating PFAS with altered kidney and thyroid function. That came out of the C8 study, came out of loads of animal studies. And this is a study done in a community in Ohio upstream of where the contamination occurred, but there was contamination from other sources, from not only PFOA and PFOS, but PFNA, PFHXS, and PFDA. And what they saw was decreased kidney function measured by glomerular filtration rate and an increase in TSH. And I want to point out that in humans, when the thyroid gets screwed up, what you tend to see is changes in thyroid stimulating hormone. In our rats and mice, what you tend to see is a change in circulating thyroxine levels. The change in TSH says that thyroid is being stressed. It's having trouble getting out, say, enough T4 in order to function normally. So we have to remember that. And the other point here is last night we heard some discussion about the half-life of these chemicals. So PFOA has a half-life of roughly 2 to 3 years. PFOS has a half-life roughly 4 to 6 years. And I say rough because there's variability in people. PFHXS appears to have a half-life of greater than 10 years, not only from this study, but there's a highly exposed population in Sweden that's being followed, and again, very, very long half-life for PFHXS. So the key question I'd say is, okay, so PFOA, PFOS, they're not being made, they're still with us, some of them will be with us forever, but so we now have replacements, and we should be asking the questions. Are they persistent? Well, I've already told you, in the environment, they're certainly going to be persistent. Are they toxic? Well, we better look at that. And toxicity, there's maybe a difference between acute and long-time toxicity. Are they well taken up? Where do they go? Can we get rid of them? And I'll come back briefly maybe to the issue of can we get rid of them. I'll tell you right now. Well, let me tell you, because I don't really think I have slides about that. But while granular activated charcoal filters, if you keep changing them, can remove it from your drinking water, the PFOA and the PFOS and the long chain ones, it does next to nothing with these new short chain ones. The only thing that we know at this point really that can well remove the short chains are reverse osmosis. And if you reverse osmosis, to put it like you could put it in under your sink in your kitchen, is not horribly expensive, but to do it for your whole house, you're talking thousands of dollars. So this is a major issue that we have to begin to think about. Okay, so what about, these are just some effects of alternatives to PFOA and PFOS on the liver. This is looking at some of the fluorotelomere carboxylic acids and the sulfonated acids. And what you can see is that especially the PFAS alternative has lots of effect on cytokines in the livers, which those are related to our immune system, and again on ones in the liver, the serum and the liver, you can see. So there are clearly effects there. And then I've already mentioned to you that the telomere alcohols break down to give you the PFAS that aren't alcohols. And so these are present, many of them as side chains on long polymers. And what happens? They don't get broken down, but they get cleaved off the polymer. And so that now you get the fluorotelomere alcohol, say in the atmosphere, and then it can break down to give you the carboxylic acid or the sulfonate. And I think we should also remember that, yes, polymers are not going to be well biologically absorbed. I'll agree to that. But to make the polymers, you've got to use monomers, things like PFOA or PFOS or PFBA, the 4-chain, or you've got to use my favorite Gen X, something like that. But the point is those things escape during production. And again, some of them can be produced during breakdown. And then what do we do with polymers that will never go away? I think most of us agree that we don't want a lot of styrofoam anymore because it'll be here a million years from now. So why are we making other polymers that will be here certainly for as long as humanity may survive? This is just a study looking, whoops, how come that didn't come up? Oh, there it is. The class comparison of PFAS in the liver. My NTP did 28-day studies in rats of 7 different PFAS, both short-chain and long-chain ones. And basically, just to give you the take-home lesson, this is looking at some of the enzymatic responses, the biochemical responses. The short-chain ones did just what the long-chain ones done. You just had to use more of them. And that's because their half-life in the body is shorter, so you have to give them a higher dose. But if you give them enough, you get the same liver effects, you get the same thyroid effects. Those were the endpoints that were looked like in that. And currently, NTP is looking at the immune response for these. I can tell you that PFDA does the same thing as PFOA in suppressing the immune response, at least in the mice where they're being looked at. So NTP has also said, wait a minute, there are 5,000 of these chemicals, plus or minus. There is no way that we can test every chemical, that's going to be made. We've got to approach something different. So they're looking at a class kind of approach that on your right is just from a paper from Wang et al., where they were kind of trying to group the PFAS into different classes. So NTP is working with EPA right now. They're actually testing more than 160 different chemicals, seeing whether they can group them based on a variety of short-term both computational and in vitro assays related to response to get some idea whether they can do that. They're also looking at 10 different mil-spec AFFFs as well. And the idea is this could focus research. Well, couldn't leave North Carolina out of the equation since that's where I'm from. But up in your right-hand corner is kind of a little bit of map of the Cape Fear River. You can see where the Keymore's plant is, kind of right by, let's see, A is upstream, B is where the plant is, and then C is where the city of Wilmington, a city of 260,000 people, that their entire drinking water supply was heavily contaminated by Gen X because Keymore was just dumping it into the river. They had said that they weren't doing it, but it turns out that they were. In addition, I should tell you, the river has lots of other PFAS in it. In fact, when Mark Streiner and Dieter Netliff and Lee Ferguson and some of the other chemists went in and took samples from the river, they could only account for 20% of the PFAS in the river. That's all that they could accurately define that they had standards for. So there was lots of stuff that they don't even know what it was in the river. And I should tell you, if you happen to live near where the Keymore's plant was, turns out there were air emissions because it was just going out the stack. And so if you had your nice garden or farms in that area, their produce was all contaminated as well. But anyhow, the group from North Carolina State, working with the group, actually people from the state and working with people from Eastern Carolina University, got together, and some folks from Duke even. That was quite amazing. They got them, well, there's a lot of rivalry in North Carolina. But anyhow, they got together and they did a community study where they recruited several hundred people from the ages of 6 to whatever, non-pregnant women. And they measured, but this was, by the time they got in there, it was 6 months after the state had said to Keymore's, you gotta stop this. And so the levels in the river had dropped, okay? So anyway, but they measured Gen X in drinking water, blood, and urine, and basically they found it in some in the water, levels were low, but they couldn't find any Gen X in the people. But guess what? They found other things in the people. They found not only PFOS and some PFOA, they also found 4 brand new PFAS that had never been reported in people before. Some of these are what we call short chains. They're ones with ether linkages, oxygen linkages between the carbons. And again, some of these dropped once Keymore stopped dumping it into the river. But again, what you can see is that the levels of the legacy PFAS, the PFOA and the PFOS, were 4 times higher than they were in the general NHANES, which is the sampling of the US population at the same point in time. So these are some couple of my studies that I'm going to show you, because I think it's important to realize, I already told you that I think, if you see something in lots of animals, it's likely to happen in some people. And I think when we have epidemiological findings, the believability of those is strengthened not only by repetition of that kind of study, but when you have animal data where you get the same kind of responses. We all know that rats are not people. Some people might be rats, but that's another issue too. Anyhow, so it's wonderful to be retired, guys. Anyhow, so what you can see, this was a comparison. Sue Fenton, who is at NIH SNTP, has been doing a series of studies, developmental studies, using mice in her model. And this is where she's exposing them, starting right from the initiation of pregnancy, throughout pregnancy, and looking, for example, at the level in the liver, and looking also at responses. But what you can see here is basically the liver levels, for example. This is comparing a dose of PFOA to Gen X. Now remember, Gen X is rapidly eliminated, but you can still see some in there, okay? But the important thing is when you look at it, you're still seeing an increase in gestational weight gain with the Gen X. And again, you can see here, whether you're looking kind of at the statistical approach or even just looking at the data. And in fact, you're seeing the same thing with Gen X that you see with PFOA, even though the levels in the liver are so much lower. So you could say it's hit and run, although these animals are being dosed every day, but getting in there, it's having an effect and it's causing a response. And then there's these effects on mammary gland development. Sue is probably one of the world's expert on rodent mammary gland development. And this is the data with PFOA, where you can see basically a dose response in basically inhibition of the development of the mammary gland. That number should be higher. As the gland develops, there's the branching of the mammary ductals that grow out to eventually give you the places that can produce milk. So you can see that as you increase the PFOA dose, that level goes, you get less development, and you see exactly the same thing with Gen X. So again, Gen X is doing the same thing. So another example of a short chain doing the same thing as a long chain. So just to remind you, and I forgot to stick bone on here, because I had made this a few months ago. I shouldn't say I made it. This is when I worked. Someone made this for me just before I left. And, you know, it's so pretty. You can probably tell the slides I made versus the ones I pulled together. But anyhow, the point here is that, you know, a multi-system toxicant, or family of toxicants, I should say. Well, I gave you two examples of community research, the one in Colorado and the one in North Carolina. But I just really want to emphasize the importance of community engaged research. I mean, people have quoted me because I say it. You can't do environmental health research unless you work with the communities. And that doesn't mean a helicopter trip. That means you get in from the get-go, because the communities, they're the ones who are living it. They know the questions that need to be addressed. And the beauty of some of this is the communities also, not only do the scientists grow, but the communities grow in their knowledge as well. So again, completely advancing the research general, it really, as I said, builds the capacity of everybody. In our country, environmental health, science literacy is terrible. Environmental science literacy is even worse. Working in communities, we can help them understand that better. We really can get youth involved. Frequently, they become the boots on the ground in many of our community engagement, our NIEHS community engagement cores. You know, there's a lot of work going on, especially with the teenagers who really get turned on. We increase diversity of the field, and diversity strengthens all of us as people. And again, you get the community involved. Even when grant funding runs out, the community is still there, and they're still involved. We need to think about cultural sensitivity when we're working with communities. Often, some of the investigators are not of the same racial or ethnic mix or socioeconomic mix as the communities in which they work, and you need to be sensitive to that. And we need to understand that in a community, there's variations even within a community that we have to be sensitive to. Gender and age, I made the joke before that if I had a problem with a computer, I'd go to my youngest grandkid, you know, but I think that's true in many places. People of different ages are going to respond differently. We have differences in language, and some of that, everybody might speak English in a community, but they don't mean the same thing. And we have to work at understanding that. And again, we have to listen as well as speak. This is just some pictures from St. Lawrence Island, which is well, it's a small island right near the international date line in the Bering Sea, about 180 miles southwest of Nome. I've been there. I paid a visit because these are some of the most contaminated people in our country. They're contaminated in part because they're subsistence hunters and fishers, so they're eating animals at the top of the food chain, whales, seals. They used to be called the walrus hunters because walrus was their specialty, but now because of climate change, and I can say that, the walrus basically, The ice, when they usually go fishing for, hunting for walrus, is in the early spring, and the ice doesn't come far. Solid ice is not far enough south anymore. The walrus are now landing up and beaching by Barrow at the very top of Alaska. They're not coming far enough south. These people are also eating the fish in the couple of streams on this island. I have to tell you this, I have to say this. So during the Cold War, there were two Air Force bases on the island that were listening stations for the Russians. And on a clear day, which I can't believe happens very often, because at least when I was there, we ended up sitting in Nome in the airport, which is just like a square box, for 2 days before the planes could fly. But when you know, on a clear day, you can see Russia. Anyway, and Sarah Palin's husband was stationed on St. Lawrence Island, and maybe that's where she thought that from Wasilla, which is a suburb of Anchorage, she could see it. Anyway, that's another issue. But anyway, I will tell you, the work that NIH has done with a community group called ACAT, the Alaskan Communities Against Toxics, where they have developed leadership roles, they've funded grants, they've trained their young people. They've actually, young people, and by that I mean teenagers and even people in their early 20s, have gone to the international meetings on POPs in Geneva, Switzerland, to talk about their situation. And they are highly exposed, not only, for example, to PCBs, but to PFAS as well. Anyway. So community engagement, I didn't know how to show all the community engagement that's going on, but related explicitly to PFAS, but what I did was highlight some words that I thought might help you, get some of the ideas of what all the different community groups, for example, are doing. And the universities, these are just ones that are working in this area really on the East Coast. Water testing, making presentations, preparing fact shops, holding workshops, holding community meetings, developing databases, providing technical expertise, working on remediation approaches, partnering with different groups, measuring PFAS in wells, developing infographics, working with state representatives, federal representatives I should say too, being on the radio, having booths at different kinds of community meetings, and doing community screening, which I think is really important. Don't see as well. Anyway, so what are some of the conclusions from what I've been telling you that I think we should be thinking about going forward? We are all exposed to PFAS. There are too many to do proper mixture toxicological kinds of testing. The PFAS are all persistent, and we think that they are all highly mobile on a life cycle basis. Therefore, we want to prevent new problems or existing problems by eliminating non-essential uses. If you don't need it, let's forget about it. And we have limits for existing PFAS contamination is more difficult. I already said we can't remediate a river system. We can't remediate, thousands of square miles of contaminated land, for example. So the key research questions that I think we should be looking at, I want to know, is what we're measuring in my blood, and at this point we routinely measure maybe 16, some groups can measure 25, there are 5,000 of these. So are we measuring 90% of what's in our blood, or are we looking at 10% of what's in our blood? That makes a huge difference. There's one paper that's been published where people tried to look at that, and in one population it was 80%, good, and another population it was about 30%, not so good. So I think we need to get better at these total organic analyses. We really have to deal with the issue of essentiality. Where are the chemicals really, really needed, and where can we replace with safer alternatives? And we've got to ask the question before we do the whack-a-mole approach. Are our substitutes any better? And I've shown you some data that says we're not clear that they are. And again, how can we address PFAS? As a class, a single class, or subclasses? So the idea of addressing chemicals as a class, I have to tell you, I mean, that's how we treat dioxins. That's how we treat PCBs. I don't understand why this is considered such a novel concept. But the National Academies, on a request from the Consumer Product Safety Commission, recently opined, after consensus study, that in fact, you could look at all the organohalogen flame retardants and treat them in a class approach. They suggested you might have to break them into several classes, but you didn't have to look at every single one. So should we think about that events that might have shifted our environmental health paradigm? For example, DDT and persistent pesticides, Silent Spring, that kind of is what led to the creation of EPA by Richard Nixon in 1970. The Chernobyl nuclear plant and the concern with nuclear power. Bhopal, India, with their terrible chemical contamination where there are, thousands, I think it was about 30 or 40,000 people died quickly. There are still impacts on people who survived. Or Libby, Montana, the asbestos contamination there. It's the only Superfund site in the nation where we actually have dead bodies. Unequivocal, with lots of mesothelioma, not only in the mine workers, but in residents of the town. So I think we want to ask, are PFAS, are they going to shift our approach to emerging chemicals? PFAS have emerged, but is it going to make us look differently as we go forward? Are the understandings that we're getting, coming out of the C8 study in Parkersburg, or in my neighborhood in Fayetteville, the Keymoors in North Carolina, or all the military bases, is it going to make us think differently? Well, it's actually 4.5 years ago that the Madrid Statement on Highly Fluorinated Chemicals came out, which said, we call on the international community to cooperate in limiting production and use of PFAS and in developing safer, non-fluorinated alternatives. Where did that statement? It was signed by hundreds and hundreds of scientists. And so my final thought is one I think we should all ask. Why do we continue to make chemicals that will never go away? Didn't we learn our lesson more than 40 years ago that we don't want to make chemicals that are very persistent? So thank you all. Do we have time for questions? Do we have time for questions?
Linda, we have just a few minutes for question and discussion, and I in particular want to remind folks who are joining us remotely that you can send in questions. We will be monitoring on this end. So about 5 minutes for a few questions.
I even kept on time. I'm pretty impressed. Any questions? Happy to answer them. Yeah.
So Ann Arbor has a treatment plant that uses
Right.
carbon to filter out PFAS and other things, but mainly they're adding it for PFAS or for these chemicals. The question is to our state environmental group. It's called EGLE now. It used to be
Right.
EQ. What do you do with the carbon? And so what they're doing is they're trying to be very careful, and they're cooking it under very high temperatures. And they say that actually, in their opinion, degrades and destroys the target chemical, and then they reuse the activated carbon. So I don't know if you've heard that, or is that something? They're very tight chemicals. They're hard to break up. I know that. They're amazingly strong. That's why they last so long. And so you have to get really high temperature, I think.
So you have to heat it to, I've heard some people say greater than 1,200 degrees, others say greater than 1,400, I've even seen greater than 1,600. I can tell you that if you go on EPA's website about incineration and ask, can you use incineration to get rid of PFAS, the answer is that hasn't been clearly shown. I think there are some people that thermal oxidation, people say can work. You may be able to do it with limited amount of material, like, say, granular activated charcoal, that's coming out of a filter. You can't do it for a river. You can't do it for a lake. So, you're treating it's a limited utility. And I would remind you that the GAC, that's granular activated charcoal, does not do a good job at removing any of the short chain. A paper was just published last week coming out of Heather Stapleton's lab, along with a bunch of others, showing that, in fact, that it really, the short chains are not well removed by that. So, I think we have to ask, these become environmental justice questions. People can't afford to put reverse osmosis systems in their house. Some people really won't be able to put it in under their sink. I was feeling really good about my house because I have a new refrigerator and it has a charcoal filtration system built into the refrigerator. Well, my house was one of the ones that Heather sampled. And, it doesn't remove a lot of what's in our waters now. So I'm, beginning to say I need to do something else. So, other questions? Yeah.
Hi. I thought it interesting to note that one of the bullets in your slides showed that these chemical contaminations cause obesity. And some studies a couple of years ago came out and said, Michigan and Ohio have some of the most obese people in the country. So I can't help but make that leap from the chemical contamination to obesity. But I was wondering, on what basis have you identified that it causes obesity?
Okay. So there are several epidemiological investigations that show it. There are a bunch of experimental animal studies that show it, and there are mechanistic studies. So the PFAS are activators of PPAR gamma, which is a specific receptor that we have in our bodies that is involved in fat production and the generation of more adipocytes. And that is probably the reason we're seeing problems with bone density, because there's almost a switch. You either go to bone or you go to adipocytes. There's kind of that switch. So I wouldn't say necessarily these chemicals are making us fat. I would say they are increasing the risk for us to be fat. Okay, and I have one gentleman here, and then we'll take the remote one.
Thank you for your wonderful presentation, first
Thank you.
But I would like to know, as far as the cooking wear and the clothing wear, what makes the chemical fall off into our food when we're cooking or when we're wearing our jacket?
Okay, so these chemicals are not chemically bonded to the surface of your clothes or your carpets or your cookware. They are added. So, for example, years ago, I know people said to me, if you have Teflon pans, don't use them on a really high heat, because that will increase some of the volatilization from the surface. So they just come off. You don't have a chemical bond linking that PFOA or Gen X, by the way, is a replacement for PFOA, linking it to whatever product you're talking about. They're just basically on the surface. And that's why we find very high levels of these compounds, like in dust, in house dust, for example. The question from the...
We are fielding questions from folks attending via live stream, and this is from Hope. And they wanted to know, how will we ever wrap our heads around banning a class of PFAS when the industry at a fast pace continues to produce spin-off chemicals? They also say thank you.
It's really difficult. It's a very, very difficult problem. But I think this is the absence of regulation has made this so much worse. States are out ahead of the federal government. There is essentially no federal regulation. EPA in 2016 issued a lifetime health advisory, which many of us think is way too high, but it was a lot better than having nothing, but it's not a regulatory rule. What Representative Debbie Dingell was trying to get through in the last Congress was getting PFAS listed as Superfund chemicals, as hazardous chemicals, which would have meant that they would fall under the Superfund regulation, which would lead to some kind of regulation. But the issue is in my personal view, I think that we need to regulate these as a class. I talked about briefly this issue of essentiality. It was a really important paper last summer that came out. Ian Cousins was the first author on it, but where he basically said, let's look at PFAS as a test of this. Let's talk about 3 classes. Its use is not really needed. I don't really need my new hiking boots to be completely water resistant. Okay? That's okay. I don't need that. So stop using it. The second class is, this is a really important use, maybe an industrial use for something that they really needed to make something. Well, first of all, you better use it so it doesn't escape into the environment, closed system. But second of all, guess what? Maybe there's an alternative, and I should say a safe alternative, something that's actually been tested before it goes on the market. Let's say so you switch to the safe alternative. And then the third class is, we have no alternative. So there may be certain medical uses, for example. And, that doesn't mean we don't continue to look for alternatives, but you would continue it in that third category. That would be a really small category compared to the tremendous amount of uses that we have. But I think there's got to be, I'm a big believer, it's the market basket speaks. We've got to get people enraged, outraged enough to say, we're just not going to take it anymore. Thank you.